All right, this set of notes is meant to help you out with equations with variables on both sides. I'm going to pop that in the objective here. All right, so when we're dealing with this, we're doing Cornell notes, so let's go ahead and put our name in. So I'm before school right now, and it is the 8th of September. All right, so our essential question is, how do I collect like terms? Let me say it this way. How do I collect variable terms on one side of an equation? So this is going to be just like any other equation you've solved, with one little exception, and that's that you're going to be dealing with problems like this. So I might have something like, I'm going to bring it up here. Give me just a second. 9x minus 4 equals 2x plus 9. And so the reason these are different from some of the equations that you've solved up to this point is that you have variables, so an x term on the left and an x term on the right of the equal sign. And so dealing with that is the essential thing that we're up to. And so we'll ask the question here, how do I collect variable terms on one side of an equation? And the answer is, I'm going to put a star here, the same way you collect constant terms. So before we get to this example, I'm going to jump down here. I'm going to look at this equation. 9x minus 4 equals positive 9. And so it's very similar to the equation we were just looking at. The difference, though, is that now we have variables on just one side of the equation, the left side. And if I were to ask you what to do, you would say, oh, you'd start by adding 4 to both sides. But let's look at what that does. It's going to cancel out this negative 4. And when it does that, I'm going to have 9x equals 13. So all of the constant terms, all the terms that don't have a variable attached to them, are now over on the right side of the equation. There are no more constant terms over here on the left side. We just have a variable term left. And so we're going to take a similar step. So I'm going to jump down here. I'm going to rewrite this guy right here. But since I'm working electronically, I can do it maybe a little bit more rapidly. Nice. And so I'm going to go ahead and start with this. So I want to get rid of, let's say, this 2x. I want to get all of my variable terms on the left. So let's say that I'm going to make my goal get variable terms on left. So I want to get rid of this positive 2x because it's on the right side and I don't want any variable terms over there. Now just like before, when I got rid of the minus 4, I had to do the opposite. I'm going to do the same thing here. Since it's a positive 2x, I'm going to take away 2x. Because 2x minus 2x gives me 0x. And so that's just going to leave me with the positive 9 over here. But when you're solving equations, you have to do the same thing to each side of the equation. So I'm going to put minus 2x over here, and I'm subtracting x's, so it's going to go right underneath 9x because that's its like term. So I'll end up with 7x minus 4 equals 9. And so I'll add 4 to both sides. And then 7x is equal to 13 in this case. I'll divide by 7. And so now I have x is equal to 13/7, which you should just type in like that when you're using Khan Academy. So there's really nothing tricky here. It's just the same kind of business you've always been doing, only now we're moving variable terms around. I'm going to add one more question here, which is, how do I decide which side to collect variables to? So if we look back at this problem, I decided to get rid of the 2x because I wanted to get stuff on the left. I wanted to get the variable terms on the left. I could have very well gone with the opposite. And so there's a reason why I chose to get rid of the ones on the right. And so my rule of thumb is this: get rid of the smaller number when it comes to the variable terms coefficient. So let's look at that's a fun little sound. Let's look at this equation here. 9x plus 1 equals 4x plus 4. So it really doesn't matter, and so I'll take this as my second note. It doesn't matter, and so there isn't a right choice. So this is just a rule of thumb. And I'm just going to look at these two numbers and decide which one's smaller, 9x and 4x. Well, 4 is smaller than 9, so I'm going to get rid of the 4x. And so I'll take away 4x is to get rid of the positive 4x, and you end up with 5x plus 1 equals 4, and you can solve it from there. So let's look at one more example. Let's say I have negative 2x minus 3 equals negative x plus 6. So when I'm looking at this one, I see a negative x and I see a negative 2. When it comes down to it though, negative 2x is smaller than negative 1x. And so I'm going to get rid of the negative 2x. And I'll think to myself, well, how am I going to make a 0 out of negative 2x? I'm going to add it, because that's the opposite of that minus 2x there. And so I'll add 2x to this side. So I end up with negative 3 equals negative x plus 2x is positive x plus 6, and you can solve it from there. And so my rule of thumb is to look for the smaller number and get rid of that side and try to collect them to the opposite side. But it's just a rule of thumb. It really doesn't matter which side you go to. When you get done watching this video, you should take the time to write a summary and try to make sense of what was going on in this little lesson here. And then good luck on the exercises.